Hello everyone, my name is Matthew Acorn and I'm here to walk you through my final project for the Digital Forensics class of fall 2016. So we all know that webmail has become increasingly prevalent. Most people do not actually download messages to their thick client anymore, as it takes up a lot of space and it really limits you because it's only really accessible from that one machine. Webmail is accessible from anywhere, and the providers give you practical unlimited storage, so most people kind of rely on those. As such, I thought it'd be a good idea to focus a forensics tool on connecting to webmail and pulling down relevant information from that webmail inbox directly, rather than doing a hard drive or a thick client forensics. The current implementation of the tool focuses on Gmail, largely because it's a pretty widely used service. It has pretty robust API, and I had a few accounts I could easily test with it. In terms of functionality, the tool will first pull down a list of the messages in the inbox, and then we'll start extracting key header data. It will also pull down the email attachment to get metadata for that, as well as the file hash. It will then parse through all of the email content, looking for any URLs that may be in there. From those URLs, we can then grab the root domains too. Within the email header, we also have the full path that the email has traversed, and we'll pull out that path information and make that available. With the URLs, domains, and hashes, we can then perform virus total searches to see if anyone has them listed as bad. Once we have all this information, we can then store it in a SQLite database. And finally, we can take the information from the database and do some quick stats, basically only looking at the number of occurrences for each sender and each recipient to kind of give you a quick idea of who the top talkers are to help your investigation. In terms of implementation, it's written in Python, obviously, and we rely on a few APIs pretty heavily. The Google API is what we use to pull down all the messages and their attachments. The virus total API is what we use to connect in and do searches on the files and URLs. And then finally, SQL Alchemy is what we use to do all the database writes and reads. I had to make a number of assumptions, and there are a few limitations to the current implementation of this tool. Everything was done in Python 2.7.6. I know for sure it doesn't work in Python 3 at the moment, but at some point I hope to remedy that. The URL for URL extraction, I assume that the URL starts with HTTP or HTTPS. That may not be true in real life, but to avoid false positives, I made this assumption up front. Right now, as I said, Gmail is the only one supported, and hopefully we'll expand that to a few others. The Google Gmail API has a number of restrictions and limits on usage. They range from the amount you can download per day, or the number of requests you can make per second, or throughout a certain period of time. This script doesn't really have any problems with the rate limits. It's more the download limit that may become a problem if you have a large inbox. But the tool is set up to allow you to stop midway through, or if it does hit the limit, it will stop itself and save its state. So you can, after you wait a certain period of time, can resume later, and you'll resume exactly where you left off before. So there shouldn't be any lost time there. The virus total API, particularly the public API, only allows 4 requests per minute, which is pretty impractical for most of what we want to do. If you have a private API, that'd be great. There's no real limit for that, but I believe those are fairly costly. So as a result, I don't have one, and that code itself is untested. But in theory, it should work if you had a private API. But again, the public API, I think on the URL side, I had, I think, over 30,000 URLs for my NYU inbox, and at only 4 requests per minute, that really won't finish anytime soon. So it's more of a proof of concept. I'd highly recommend using a private API if you really want to do the use of VirusTotal. There are a few error codes that Gmail API throws out for those limit rates and the bandwidth errors. I tried to force that to happen, but it wasn't really cooperating and giving me the error, so it's not as robustly tested as I would have liked. Finally, when writing to CSV, I removed any of the commas in metadata and replaced them with semicolons just so that it looks better when you open it up into some sort of Excel spreadsheet or like LibreDocs. Right. In terms of execution of the code, you need to set up the APIs. There's a few links here that can help you get that set up. It's fairly straightforward. In both cases, you'll end up with files stored in the same location as the script. That was helpful for me, so I don't have anything hard coded into the code. I don't risk leaking my own API keys, which would not be pretty to have access to my email. In terms of running command, there's a number of flags that allow you to run it. We can go. I'll go through that a bit later when I do the demo. But you're just going to specify the mode you want to write it in, and then you can specify if you want to write to a CSV, write out the statistics, and then of course make the VirusTotal calls. It was very important to make the VirusTotal calls optional because, as I mentioned, they could take forever. So they're most of the time when I ran this, I did not include them. There's also the resume flag, and that's when if you stop midway through, if you want to start up again to continue where you left off. In terms of output, we're going to have a database with a number of tables with all the metadata that we've extracted. You also have some CSV files if you choose to write to CSV, and also just the CSV representation of the database. Finally, if you choose to write the statistics, you'll get 2 stats files with the sender and recipient stats, which you can then use for your investigation. In terms of future enhancements, I would like to do support for a number of other webmail providers. I think Yahoo and Outlook Mail would be on the top of that list, but a lot of work needs to be put into that. I'd like to be able to open PST files. Although I mentioned I focus more on the webmail side, it would be useful to be able to open up a PST and extract the information from there as well. One simple thing that I could probably do here is taking the hello string and doing a reverse DNS lookup, and then compare with the IP of the originating server. This is sort of in support of anomaly detection, looking for something that stands out, a forged hello string or something along those lines. I'm certainly not a Python expert, so my code may not be as pretty or as extensible as it could be. I would like to refactor the code to class format and try to abstract away some of the specific webmail provider implementations. Right now it's not as important because we're only focusing on Gmail, but as we get more providers, it would be nice to have classes and just sort of make each class like an instantiation for the specific webmail provider. And as I mentioned, I really would like to get the code working in Python 3, so that's something I'll work through. All right, so rather than going through the screenshots, I think I'll switch over to my desktop here. All right, so I'll quickly just run through the code here and highlight a few things. Lots of comments up here. So the first section of the code is really just focused on getting the database table structure set up. just declaring the classes associated with those. Fairly straightforward things. The next is the Google API setup. This is just how we create the credentials when you connect and store that into a JSON file. This is basically straight from their API tutorial, so nothing I really did myself there. These Google API calls, again, actually a lot of these are straight from Google themselves, with a few extra things from me if you actually check your error checks. From here on, you're looking at how you're grabbing the message details and the route information. One thing I'd like to point out is the URL portion. The email structure was kind of, you had to work through it and parse it, sort of a huge nested structure of body components there. So I had to create a recursive function to pull out those parts of that, the nested structure there, and search each of those for the URLs to make sure I didn't actually miss anything. All right. There's a few helper functions I created for resuming if you restart after stopping halfway through. These just help us get to a clean state and for when we restart. Virus total, pretty straightforward, just basic functions to get the key and to make a request to virus total to get a score for the URL or the hash. There's a wrapper function to ensure that we call the right functions based on the flags set at the command line. The last function here is just the one where we pull data from the database and calculate the stats on the sender and recipient. And there's the main function, which has the argument parser and just the running based on the different flags set by the user. And that's pretty much it. We'll just quickly go over here and run it really quickly. All right. So first I'll just run it in the full mode, which will do the metadata for the email, the attachments, the URL, and domains. All right. First it gets the list of messages, and then it will start pulling the metadata. And I'll give you a little tracker here to show you how far you've gone. I'll just, we could be here for a while, so I'll just stop it partway through. Like I said here, you could resume later if you really want to, but we're just going to demonstrate part of the functionality. All right, now I can run virus total. I'll do the virus total on domains that were extracted. When I run it without the mode specified, it actually is working off of the existing database. It's not going to make Google API calls anymore. So it should be fairly quick. You can see here, it obviously stopped after 4 requests, and then it will wait a minute to make 4 more requests. This is to make sure we don't go beyond our usage agreement with virus total. But we'll be sitting here for a while, so I'll just stop there. I think that's sufficient. And finally, what we'll do is write CSV and write stats. This also works off of the existing database. So if we don't specify that, the mode select is actually quite quick. All right, we'll take a quick look at the database here. All right, so we'll quickly browse the data. So you can see these are the URLs that were extracted from the emails, the domains. You can see I ran the search, and the first 4 came back. They found them in virus total database, but they had a virus total score of 0. which is good, which means nobody says that they are bad. The message route, you'll see multiple lines per message ID. That shows you the route of how it traversed, where it came from, its IP, and who received that from the originating server. Attachments, I guess in that set of messages there's only one attachment. And you can see the MIME type and the hashes there. And then finally, this is the email metadata, so you can see the message subject and all the interesting details that you need in your investigation. I'll quickly show, so here you have the CSV representation of the email metadata. So that's, we've created a number of these files for each of the database tables. I won't go through all of those, but it's basically the same as this. In terms of the recipient stats, pull that up. So in terms of, in that set of messages is checked, obviously apparently I sent 3 messages to the professor. The data is much more interesting if you run it over a larger set of messages. You should see a lot more here. And then the sender stats. Yeah, this is obviously Joseph Anderson seems to be sending us quite a few messages. But again, this would be more interesting with over a larger set of messages. And I believe that is basically it. If anyone has any questions, feel free to send me an email. My email address is mla391@nyu.edu. And well, thank you for listening.